Hello everyone. Today I am going to explain another MATLAB code which is mainly to find the even and odd component of a general signals. As already discussed in the theory class, based on the symmetry, the signal can be even symmetric signal, odd symmetric signal, or general signal. So even symmetric means x of n is equal to x of minus n. Odd symmetric means x of n is equal to minus x of minus n. And general signal means which consists of both odd and even component. So how can we find out the odd and even component of a general signal in MATLAB? For that, this is the code. So before that, theoretically, let me explain quickly about the process. Let me explain the process of how to calculate the odd and even component of a general signal. So based on the symmetry, the discrete time signal can be even signal or odd signal and general signal. Even signal means x of n is equal to x of minus n. Any signal x of n, if it follows this, then it is even signal, and odd signal means if it follows this x of n, any signal x of n, if follows this x of minus x of minus n. And the general signal any signal x of n is the combination of some part even, some part odd. So let it be x even of n plus x odd of n. So now to find out this even and odd component of the signal, what we do is just replace n by minus n. So therefore x of minus n is equal to this only. Just you replace n by minus n, and now this x of minus n will be, since this even part already, as I have mentioned, this even part means x of minus n is equal to x of n. So therefore x even of minus n will be x even of plus n, because this part is already odd symmetric, even symmetric. So this will be equal to this, to minus this odd part will be minus this. So now if this is your equation 1 and if this is your equation 2, so what we can do is equation 1 plus equation 2 will result, if we add it up, so this will cancel out, so this will be twice of this, twice x of this, twice of this, twice of this, and is equal to x of n plus x of minus n. So finally this 2 goes that side, so it will be half of x of n plus x of minus n, x of minus n. Similarly, if we subtract equation 2 from equation 1, then we'll get x odd of n, which will be half of this minus this. So this is your even component and this is your odd component of the general signal x of n. So what should be the procedure? Procedure is, for the given signal x of n, what you need to do is you need to find out the folding. This x of minus n is nothing but the folding. Then you need to add it up. So the folding part is already we have done in the class, how we do the folding of discrete time signal x of n. Then while adding, what need to do is you have to maintain, as we already did in the signal arithmetic, the signal addition, that while adding the signals, first of all, sample by sample, that is corresponding time indexed samples values are being added. Also, while doing it in MATLAB, both the matrix vector, row vector must have the same length. So we have to maintain that. So this adding up xn plus x of minus n, then scaled it up by half, 0.5. Similarly, x of minus folded signal is being subtracted from x of n and finally scaled up with half to get x odd of n. So this is the theory behind the calculation or finding out the odd and even component of any general signal. So let's see how it can be done in the MATLAB. So again, this free task is consolation task. In my previous lecture also I have mentioned the meaning of this. Now again the same thing, while taking up any signal, the first thing is to take the starting time index of the signal. So enter the starting point of the signals. Then next part is always to get the signal values. Then this here I am using k to calculate the length of x, and from this k and n1 we can calculate the ending time or the stop time index of the signal. So k plus n1 minus 1, and finally the time scale is n1 to n2. And for plotting, again we are using the subplot. Already we discussed this. 2 to 1 means we are dividing the figure window into 4 sections, 2 rows, 2 columns, and this is the first figure. And for discrete time signal, the plotting function is same. X-axis is your time axis and y-axis is your the signal value x, and grid is to get the grid line in the signal in the plot, and the title, this command title is used for giving the title of the figure or the plot with the font size setting. Now folding. So second part, what we need to do is the folding. For folding already we have done. So it is 180-degree rotation in its origin, keeping the origin value same. So the time scale, your n1 becomes, the n1 was the leftmost and 2 was the rightmost time index. Now n1 becomes the rightmost, n2 becomes the leftmost, so it is negated. m1 is equal to minus m2, m2 is equal to, this is my new time index. So my now starting time index will be this minus m2, ending time index will be my m2. So therefore new time scale, so nf I am considering the time scale for the folded signal, m1 to m2. Okay. So here I am creating one zero matrix. This is not so necessary, but you can make it a zero matrix of k number of samples. What is k? K was the length of the signal, original signal. As many sample was there, that many folded, that many samples I am considering for the folded. And using a for loop, I am creating the folded sequence. So how we explain this? Just for example. For example, suppose x of n is equal to say 3, 5, say 6, say 2, say 9, say 7, say 3, say 6, 8, and suppose this is suppose somewhere here it is my starting, that means origin n is equal to 0. So your n1 here in this example, n1 is, if it is 0, so minus 1, minus 2, minus 3, so n1 is minus 3, and n2 is your 1, 2, 3, 4, 5, so n2 is your 5. So my time scale n will be equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So this is my time scale. Okay, so this is my time scale. Okay, now for folding, I have considered m1 as the starting time index. So what will be the folded time starting time index? So this will be my first, so minus 5, and 2 will be my, so minus n2, that is minus 5, minus n1, that last 4. So when time scale, say nf I am considering, so nf will be equal to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1 2 2 3. So this becomes my new time scale. Now the values, how we will get the values?
Yeah.
So the value that was there in the +5 will now be at -5. So I am considering XF as the folded time sequence. So it will be 8, and whatever be the value at +4, that will be at -4, then 3, then 7, then 9, 2, then -1 will be at +1, 6, then 5, then 3. So how it is? This 8 comes here. Okay. Then this 6 comes here. Then this 7 comes, this 3 comes here. Then this 7 comes here. Then this 9 here. 0, that this 2 is at the same position. Okay. Then 6, this 6 is here. Then this 5 is here. Then this 3. So it gets 180-degree rotation. Okay, so that is being done here for I is equal to length of signal xf of I. So I is 1, x of k. Okay, x of k. Now this k was the length of the signal. Okay, so you cannot use further the k, because I have used the same k here, or otherwise what you can do, you can assign another variable here which will be equal to k. So x of k, k is your, say in this example it is 1 -3 to 5, so it is 9. So k is your 9. So the 9th sample, that means this sample is my first sample now. So therefore k minus 1, next time k becomes 8. So that this was the 8th sample. Now the second sample, because that second time I becomes 2, and so on and so forth. So this becomes your folded signal, and finally it is plotted here. Now as I mentioned before, going to the next step is to add and subtract. Both are same only, just addition and negation. So before adding you have to map. So this mapping. So already this part is being explained in the previous example, previous experiment. So first we need to put zeros. As you can see here, now this is your one signal with this time, this and this with the time information, and another signal is this with this time information. Okay, so as you can see, this signal is at -3, now this signal is at -5. So here you need to put 2 zeros. So how will you put zeros? This n1 minus m1. So -3 minus minus plus, so 2 zeros. So you see these zeros 1 comma and 1 minus m1, then the values of x. And in this side, this is ended at 5, but this is ended at 3. So here you need to put 2 zeros, but here don't. But to make it generalized, you have to put this common zeros 1 comma m2 minus m2. So m2 is now your 3 and m1 is your 5. Sorry, m2 is your 5. So 3 minus 5 is minus 2. So 1 minus 2, zeros 1 comma minus 2 will be an empty matrix. Here there won't be any zeros. Similarly here there won't be any zeros, but here there will be 2 zeros in this given example. And the final time index will be from what? Minus 5 to plus 5. So minimum in this side, in the left hand side, minimum of minus 3 and minus 5. So minus 3 and minus 5, minimum is minus 5. And in this side, maximum of 5 and 3, that is 5. So minimum m1 n1, maximum of m2 n2. So finally, the resultant signal will have the time scale s1 to s2. Next is just the addition. So this part, addition and being scaled up by half. So together we can do it here. Suppose x even, half dot star, because half will be being scaled up by every value of the signal. X of this, it is your x underscore L or underscore 1, xf underscore 1. So this is the after mapping the original signal and after mapping the folded signal, and similarly the minus, and finally the plot. That's all. So if you look at, if we do it so we'll just run it. My computer becomes slow. I'm running it again. So enter the starting point of the signal. Let us take this same example. So my starting point of the signal was minus 3. So minus 3, enter the signal values. While giving the vectors, you have to put it in a square bracket. So these are my values. Okay. So as you can see, so this is the discrete original signal, minus 3 to plus 5. Now this is a folded signal, minus 5 to 3. This is the even part, this is the odd part. Let's see here whether the result is correct or not. So my n is this, x is this. Okay. Now the folded signal is x of f. Folded signal is x of f. So x of f is this. Now x1, the zeros, xf of 1, this with these zeros. So the result is XE and XO. So XE, sorry, caps lock gets on. So XE. So as you can see, X even. So XF. Acha, these two. So 0 plus 8, it is 8 and half. So 4, 6 plus 3, 6 plus 0, 6, half 6, 3 plus 3, 6, half 3, 7 plus 5, 12, half 6, 9 plus 6, 15, half 7.5. So it's good. Similarly, X odd. Yes. So that's all. So that's all. Thank you.